So in this video, I want to introduce you to a new system of numbers called the complex numbers. So let me give you a little bit of a background. Okay, so when you first started school, the first set of numbers that you ever encountered were the counting numbers, right? 1, 2, 3, 4, right? So that set of numbers, 1, 2, 3, 4, and so on, those are called the natural numbers. And those are the first set of numbers that we encountered when we're in elementary school. And then the natural numbers, they're part of a bigger set of numbers that includes 0. So 0, 1, 2, 3, 4. Those numbers we call the whole numbers. And you worked with those for a while, right? When you were in school. Then all of a sudden, you were introduced to negative numbers. So now you had your counting numbers and your whole numbers, but you also had their opposites, right? -1, -2, -3. And this set of numbers we call the integers. Okay, so that's cool. That was working along fine until you had to talk about half of something, right? So now you needed to talk about fractions. So you need to take all these numbers and add to them the fractions like 1/2 or -2/3, right? And then you remember that 4/2 is also 2, right? So this bigger set of numbers here, these are called the rational numbers. And these are numbers that can be written as a fraction or a ratio of two integers, right? And so again, we're building this umbrella. So a natural number, those counting numbers, notice that those are in all these sets. A natural number like 1 is also a whole number. It's also an integer, right? And it is also a rational number because we can write 5/5, a ratio that also means 1. So notice how we're building the numbers. Then somebody decided to measure a circle and realized that there was a ratio coming up there that was pi, right? And that pi could be represented by a decimal, but that decimal, it didn't end and it didn't repeat, right? And so now we have a whole new set of numbers called the irrational numbers. Okay? Now notice I'm putting the irrational numbers in their own line here with the rationals because a number cannot be both rational and irrational at the same time. Okay? So we had irrational numbers were pi, other irrational numbers, the square roots of not perfect squares like square root of 2. If you put that in your calculator, you'll see that you get a decimal that doesn't end and doesn't repeat. So all non-repeating, non-ending decimals are irrational. Okay? Non-ending, non-terminating decimals. Okay, so now together, all these fractions and all these irrational numbers such as pi and the square root of 2, they make up a set of numbers called the real numbers. And those are the numbers you've been dealing with in your math classes up till now. Every fraction, every integer, 0, pi, square roots, cube roots, all of those numbers are real. Okay? All right, well, but then mathematicians, you know, they were not satisfied with that. They said, how come we cannot take square roots of negative numbers? So they realized that they needed to create a whole new set of numbers that would allow us to take the square roots of negative numbers. So they came up with a new number called I, right? This I is defined as follows. When you square I, you get a -1. Okay, so that's the definition, right? Or you may see it this way. This new number I, is equal to the square root of -1. And we call I an imaginary number. Okay? And now I is part of another set of numbers called the complex numbers. Okay? So here's the thing. the real numbers are part of this bigger set. So now we've got a bigger set of numbers than you've ever worked with before. That includes all the numbers you've worked with up till now, but also includes these numbers that will have this imaginary number called I. Okay, so now let's look at how we can work with I a bit. All right, so here's an example. Okay, square root of negative 16. So up till now, you may have been saying, when you see something like this, you may have been saying, oh, well, that's not real. Not real. And then stop there. But now we can actually use this new set of numbers to find the square root of negative 16. And here's how we're going to do that. We're going to split that up into the square root of 16 times the square root of negative 1. Right? Because negative 16 is equal to 16 times negative 1. And so that's the square root of 16 is 4. And the square root of negative 1, well, now you're going to write this new number I there. So we say that the square root of negative 16 is 4i. All right? Okay, look at this guy. Negative 5 times the square root of negative 64. All right, so negative 5 is like a coefficient. We're going to leave it alone for a minute. But now over here in the square root of negative 64, we're going to break that up as the square root of 64 times the square root of negative 1. Okay, so the square root of 64 is 8, right? We're going to multiply that times the negative 4. Negative 5. And the square root of negative 1 is this new number I. And so we can multiply those two coefficients together, those two numbers, and we get negative 40i. All right, let's look at the square root of negative 45. Okay, negative 45, well, we know that's equal to, we can write that as the square root of 9, right? Times the square root of 5. So we're still going to take out any perfect square factors, right? And square root of 9 times square root of 5 times the square root of negative 1. Okay, so square root of 9 is 3. Square root of 5 stays in this radical, and then there's this I. Now notice how I'm not going to write the I inside the square root. Be careful about that, okay? That does not mean the same thing. So you may see this imaginary number. We call this an imaginary number if it's got the I, okay? You may see this imaginary number two ways. You may see it like this with the I kind of on the side, or you may see it as 3 times I square root of 5. And these mean the same thing. All right, so we're going to talk now about a whole new set of numbers called a complex number. So these three examples gave us numbers that had single term with an I in them, right? And we call those pure imaginary numbers. Just a little vocabulary. So a pure imaginary number means you have a single term with an I, okay? But complex number actually has two terms. It's very interesting. So even though it's a number, the number itself has two parts to it. So for example, 1 plus 4i would be considered a complex number, and the 1 is the real part of the number, right? Because that's a real number. Those are the numbers you've dealt with all your life until today, right? And then the 4i is going to be called the imaginary part of the number. But the 1 plus 4i in its entirety together, those two together, is an example of what we're calling a complex number. All right. So now go to the next video where I'm going to show you how to add and subtract complex numbers.